I mostly wanted to cover chapter 5, and there's not too much here, so I didn't want to spend a full week on it. So I think it'll be good to get through this week along with chapter 4. And I have a couple articles to go through here first too. Are there any general questions before we get started?
I have a quick question. So is chapter 4 quiz
Yeah.
going to be on the chapter 5 and chapter 4? Like section.
No,
Okay, just chapter 4.
it's the quiz is really just chapter 4.
Okay.
Okay, any other questions? Okay, I created this short exercise here, exercise 5. It's just kind of a reflection on a couple of these articles. Just briefly go through these articles. So, can you hear me okay? I'm on a hotspot today, but I can switch over to a different Wi-Fi if it's better.
Yeah, I can hear you.
Okay, let me know if it's cutting out or anything. So these articles are about automation, and this is actually quite fascinating, actually. So, you've probably heard of the self-driving cars like Tesla and so forth. It's looking increasingly likely that the freight trucks will ultimately be self-driving, especially the long-haul ones, like the ones going East Coast to West Coast and so forth. And this article in part talks about kind of political implications of this, because there are 3.5 million truck drivers that are somewhat, not highly educated and not highly skilled necessarily, that could potentially be put out of work, and kind of the political implications of that. So it's kind of an interesting article there. And then this article is talking about more automation as a result of COVID. And we've seen this really with things like Amazon, how Amazon has taken off while some of the smaller shops have been essentially put out of business and so forth. So they're talking about like COVID largely kind of accelerating that trend. And another call out here too is that as those jobs shift, it also creates a lot of new jobs in areas like tech support and the software development and so forth. So it's not so much that jobs are disappearing, they're just kind of changing in terms of the nature and the industry and skills and education required and so forth. So those two articles are part of this exercise 5. You can still hear me okay, right? Because my the connection looks like it's a little slow.
Yeah, we can hear you.
Okay. Then this is also really, these second articles are not really part of that exercise, but I thought I'd still highlight them. This is actually a really fascinating article too. Is there a question in the chat? Yeah, the exercise is due this week. It's really short. It's just really just a short reflection on the readings. So when I worked on a dev team, we had this joke where if we got annoyed with each other's emails, we'd call them e-waste, meaning that it was just a junk email that wasn't worth the electricity that it took to power the server to send the email. But this article really talks about that on a more serious note. We hear a lot about saving trees and not printing stuff to paper when it's not necessary. But this is talking about the huge amounts of energy and electricity that are required to power the data centers that essentially store all of the emails and all of the digital music and streaming data, social media data, photos, all that stuff. So just even if the data is archived, it's still stored in a data center, and just the massive amounts of energy required to power those data centers. So it's just a really interesting take There's so much emphasis on not, not burning fossil fuels, not consuming paper products, and yet the digital mediums too actually consume a lot of energy too. And then also this week, we're going to talk about the code to generate random numbers. And I have a slot machine example here for the code samples. But I was going to review this too. This is actually really interesting. So has anyone gone into a casino and used like a slot machine? Or do you know what a slot machine is?
Yeah, you put like coin in and then you like pull the lever or something and then it rolls. I don't know.
Yeah. So actually, here, I'll run this program first before we go back to the article. Where did this go? There we go. Okay, and I'll talk about this code in a little bit. This is a little more advanced than we've covered so far. Okay, so is there a question? Oh yeah, that's a good point. So most of the casinos, I'm not sure if you have to be 18 or 21, but there's an age limit. But I'm sure you've seen this even in video games. So I'm going to enter 100 here and two units to bet, and it pulls up this kind of old style of slot machine. So it's got 3 cherries here. I pull the handle, and you're trying to get a match, right? So if you get 3 of a kind, that would be a match. If they don't match, you don't win.
Is this like completely random?
Say that again.
Are the answers completely random?
Yeah. So this code is generating 3 different random numbers. I'm not sure how many different options there are here. Maybe it looks like there's actually only 3 different options: bell, grape, and cherry. But when they're all the same, then it produces a match, and then the bet would win. But what I want to call out is, so historically, these were mechanical machines. So you would, as someone just said, you'd pull a mechanical lever and the wheels would spin, and where they stopped would result in the symbol displayed, right? So it truly was random, and you could spin it and you could get, 3 grapes one time, spin it again and get 3 grapes the next time. Essentially anything could happen, right? It was truly random. The computer programs that generate quote unquote random numbers, if you're generating a so-called random number let's say between 1 and 100, each numeric value will have a 1% chance of winning, right? So the chance of that number being the number 7 is 1%. It's about one out of 100. Where the computer programs differ from the mechanical gambling devices is the computer programs and slot machines and devices are programmed to be random. So how do I describe it? They will be predictably random. So while the number 7 will have a 1% chance of winning, it likely will only win 1% of the time. Whereas with the mechanical gambling machines, it might land on the number 7 10 times in a row. That generally will not happen with most of the programmed so-called random values. So it will evenly distribute the random percents equally. And because of this, if you go to Vegas or even some of the Indian Native American casinos, most of the gambling games are computerized, right? You can still go up and play poker with a deck of cards, but most of the slot machines and other machines in there are computer programs, basically. And they can actually plan their budget months in advance because they know exactly how much they will have to pay out next month in winnings, because it's programmed, right? So you might walk up to the machine and it may say, you know, you have a 5% chance of winning the jackpot here. That literally means it's a 5% chance of winning, not 1%, not 20%, 5%. Whereas in the traditional mechanical gambling machines, it truly was random. I mean, yes, there was a general bell curve, normalized curve there of chances, but in essence, you know, some abnormalities could happen in terms of someone could win or lose for an extended period of time. Does that kind of make sense? So, you know, so I mean, the call out is if you're ever working with something like that, just know you have to be aware of how it's programmed. Because yes, something like that, it will randomly select a number between 1 and 100, but it also kind of does it programmatically. It's not not happenstance chance. Okay, so I think, let's see, I think those are all the articles. Okay, so chapter 5, and again, there's some key points here I want to cover, but it's not too much. Okay, any other questions before I go on? Okay, so the textbook really likes this fence post analogy. I don't want to spend too much time. This is not my favorite analogy per se, so I'm not going to use this explanation. So I'm going to start right here. So while loops. So we've already looked at for loops. Okay, so the syntax of a for loop, you might have like for int I equals 0, I it's less than 3, I plus plus. Right, and then we have code in here that will execute. So we know how many times this is going to execute. It's going to execute I equals 0, I equals 1, I equals 2. So 3 times, right? So these are for scenarios where we know exactly how many times we need to loop. That's a standard for loop. With a while loop, we do not know the number of times it's going to loop. We're going to continue looping as long as a certain condition holds true. So here, you know, for loops might be, okay, we want to print the word hello 10 times, find all the prime numbers up to a certain value, and so forth. An indefinite loop, we're going to continue looping until some event has occurred. Maybe the user has typed Q to quit. Maybe it's a video game and you've lost your last life out of 5 lives and the battleship's been sunk. You know, some event has occurred, but we don't necessarily know when that's going to occur. So the while loop continues as long as that evaluation condition inside the parentheses continues to be true. So, you know, you could have a situation like here, while number is less than or equal to 100, and then inside the while loop, we increment the variable by 1 each time. That would be predictable. But if it's while input does not equal Q for quit, then we don't really know how many times it's going to loop until the user basically quits out of that. Okay, any questions on that?
What's the difference between while and if?
Difference between while and what?
If.
Oh, I'm
Um,
sorry, I didn't.
I'm sorry. If, while and if.
While
If
and
statement. If statement.
if statement.
Yeah.
So so a while statement produces a loop, right? So we would continue looping and executing all the code inside the loop as long as the condition here holds true. So like while input does not equal Q for quit. So we loop, and as long as the input does not equal Q, it continues looping. An if statement is a one-time check. So in this loop, we might say if input equals, yes, y for yes, then do something. And so maybe that's system.out print line continue. So the if statement is a one-time check, but the while generates the loop, kind of like the for statement. Now, here's one thing I want to call out too. Let me see if I have. I guess I can do it in Notepad, but I ran out of time. I didn't get a chance to find all the code I wanted to find. But let me check here. Well, I'm going to go back to Notepad just because it's more simple. Okay, so I'm going to make this while I is less than 10. And we start off with I equals 11. Okay. So I equals 11, and then we come down and we hit this while loop while I is less than 10. If I is not less than 10, we never execute the code in here in the while loop. So if this condition does not evaluate to true, the program flow never enters the while loop.
How many times is it gonna loop?
Well, so here I is 11, so I is not less than 10, it will not execute any of the code ever inside the while loop.
Then if it was 9 or 8.
Well, I mean, it would depend on what I put in here. If I have an increment here like I++, and we start off with I should almost move this into Eclipse to execute this. But if I say I equals 8, so I starts off 8, we come down here, it's less than 10, we go in here, I gets incremented, now I equals 9, we loop again, it gets incremented, now I equals 10, it's no longer less than 10, it would break out of the while loop. So it would only get incremented up to 9. Now, the main difference I want to call out here, that's a pure while loop. Then we have do while loops. Okay, so in a do while loop, it would be written slightly different syntax. So we would have do, and then we have the code inside the braces. And then after the code section, we might have while I is less than 10. And let's start off I at 15, okay? And then inside the loop, I say I plus plus. Expand this a bit. Okay. So we have int I equals 15, and then I have a do while loop, do, and inside the curly braces I have I plus plus, and then the evaluation condition is while I is less than 10. Any guesses here on what would happen with this code?
It doesn't look like it would ever actually run because you're starting at 15. and
Yeah,
you're
exactly.
implementing it
So
higher.
this is one difference between a while loop and a do while loop. With a do while loop, it does the code one time, no matter what, one time, and then it checks the while condition.
Oh,
So here, int I equals 15, do does the code, okay, I plus plus, so I equals 16. Comes down here, while I is less than 10, it's no longer less than 10, so it quits. So with a do while loop, and this is like a classic test question too, with a do while loop, it will execute the code inside the braces one time, at least one time, and then it checks the while condition. Whereas with just the pure while loop, it immediately checks that condition. If it's not true, the program execution never falls into the code section. Okay, any other questions about that?
Yes. Inside do, is it only incrementation or can there be other functions?
Oh yeah, I mean, this could be any code in here, print line statement, whatever. This is just determining if the code inside the curly braces gets executed at all, basically.
Thank you.
And similarly, we could have statements in here like get user input, a scanner object with an input.next line and so forth. If the code hits a break statement, just a simple break statement, then the execution will break out of the loop and continue on through the program. Okay, so I mean, really the main thing I wanted to focus on there is the difference between a while loop and a do while loop. So a while loop, it evaluates the condition. If it's not true, never executes the code. A do while loop executes the code one time and then evaluates the condition to determine if it should continue or not. Okay, so this is how to generate the random numbers. So we import java.util.star, and next int returns a random number. We have next int max returns random integer in the range 0 up to max, or next double. So here we declare a random number named rand. The keyword is random. And again, we have to include import java.util equals new random. And int random number rand.nextInt will return a number between 0 through 9. So one of 10 random numbers. And then there's slightly different syntax here for different ranges and so forth. So int n equals rand.nextInt 20 plus 1 will determine a random number between 1 and 20, including 1 and 20. This is to generate random number between a range of min and max numbers. This is between random number between 4 and 10. So the syntax changes slightly, but the keyword here again, is random, and you have to include import java.util library. And that's what that slot machine program is using for that. Okay. See, oh, this textbook kind of skips around a little bit. So this is what I was looking for earlier. So this is the do while loop. So again, this is the syntax. So do code statements inside the curly braces, and then while with the test here. Okay. Whoops. We kind of talked about the string methods on Tuesday. So type Boolean. So Boolean is a data type which essentially evaluates to true or false. So the key word is Boolean. That's a data type, like saying string or int or char or double. Here, minor or is prof or love CSE, that's the variable name. So those could be named anything. And the values evaluate simply to true or false. So again, with this type of programming, you could use something like an int to use as a flag instead of equal to 1 or 0. But it's better to design if the values have to be one of two different values, like true, false, on, off, active, inactive. It's kind of better designed to use a Boolean value to represent basically just true and false. On like web design.
What are those parallel bars like minor, is prof, love, CSE?
That's the or operator. So so if minor or is prof, or if this, then output this message. They're kind of using, yeah, this is kind of, they're kind of combining stuff to produce the logic there. But that's a or operator. So. Let's see. Okay. So here, this is a good example. So here's a method. The name of the method is prime. It takes a parameter argument of int n. It returns a Boolean value and it's public static. So int factors equals 0. They have a for loop for int I equals 1, I is less than or equal to n, I plus plus. And then here, after that executes, if factors equals 2, return true, else return false. So this method will simply return a true or false value. And then here is how you would check those return values. So here, if is prime 57 equals true, or if is prime 57, these would both execute if that value returns true. And again, this is double equal sign because we're not assigning the value. We're not saying is prime equals true. We're saying if is prime of the value 57 equals true. So we're checking the value there. Um, this will not be on the test. This De Morgan's law. This is one of those slides I need to kind of edit out of this presentation. Okay, any other questions about the Boolean data types or Boolean values? Okay, and then chapter 5 talks about, they use the keyword assertions. Later in the quarter, when we talk about data files, we'll talk about error handling, try-catch blocks, and assertions. And that's not what they're really talking about here. It's kind of a misleading use of the term assertion. They're talking more about confirming the values of variables and so forth. So just know that later in the quarter, we'll talk about error handling and assertions. That's not really what they're talking about here. Okay. Okay, that's mostly what I wanted to cover in the slides. And again, chapter 4 quiz is on chapter 4. There's not gonna be a quiz on chapter 5. Let me just go through some of the source code examples here really quickly, and then I'll answer questions about the homework, and then I'll let you go. Okay, so this is you probably played the game maybe when you were a kid of like guess a number between 1 and 100, right? This is a simple example of that game. Let me just run this one time before I walk through the code. Okay, so guess the number between 1 and 100. So I'll start off 50, lower, so I'll say 25, higher, I'll say 40, lower, 35, lower, 30, higher, 32, higher, 33, higher, 34. So that was actually a, when I guessed, I used a binary search algorithm where I'm basically splitting the range in half, and then depending on if the value is higher or lower, then I take that half and split that in half, and I keep splitting the range in half more or less until we pinpoint the number. So, so again here, let me just walk through this. So we have package chapter 5 that matches the name of the package. We import java.util. Here's the beginning of the class, guess. Here, line 9, they declare a constant variable. So public static final int max guess equals 100. So we know it's a constant because of the final keyword. And the data type is int. The name of the variable is max guess. It's all caps. It would still work fine if it was not all caps, but that's kind of the syntax and good coding style to make a constant all caps. So we know it's a constant. And that's set equal to 100. So the value of that variable cannot change in the program. We would have to change it in the code right here. So anywhere in the code where you see max guess, you know that value is equal to 100. And then here's the beginning of the main method. So public static void main string brace args. Here they declare a scanner object, and this is for the user input. So scanner console equals new scanner system.in. So all of this is standard syntax, except for the word console. That could be named pretty much anything we like. Then here, they call the method give intro. So we know they're calling a method because it's got the 2 parentheses here. So we know that's a method call. Give intro is not really a Java reserved word. So that's kind of an indicator that this is probably just like a custom name of something like a variable or a method. But again, with the parentheses, we know it's a method. And there's no variables being passed to it. So they're calling the method give intro, but nothing's being passed to it. So if we go down and look at that method, we can see what it does. And again, we're still in the class right now, but we're not in the main method. The main method is right here. So we're still in the class. We're not in the main method though. We're in this custom method. So public static void give intro. Return type is void, so this is not returning anything. And it's basically just printing out a series of println statements. And here it brings in, so I will think of a number between 1 and end quote plus to concatenate the string, and it brings in the value of max guess, which is set to 100. Okay, any questions so far before I go on?
Could you have written constant int max guess? And what's the difference between public static final and constant?
So the final keyword is what makes it a constant. This would work fine without the final keyword, but then the value could be changed. So with the final keyword, it like locks in the value to say this is a constant. We won't let you change the value. Public static, we'll talk about more later in the quarter, but it's like a security scope range modifier. So public, it can be called from anywhere in the program, basically.
Then what about private?
Private, there's a whole different series of scope limitations to it. So if variables are private, they cannot be called from other classes. So you might have, and we'll talk about this later in the quarter when we talk about the object-oriented design and class structure and multiple objects. But if it's private, then if there's a method in a different class, it cannot access that variable. It's like a scope modifier. Kind of like, if there's a apartment building on Main Street, that's private property. You can't necessarily just walk in there, but a park is public. You can walk in the park. It's like a access limitation. And does that make sense?
Yeah, that was clear. Thank you.
Okay. And then later too, we'll talk about set and get methods. And I don't want to go too far into those, but basically with those, we have private variables, but then we have public methods that can change the variable value or get the variable value. And they kind of act as kind of like gatekeepers to the variable. So, but we'll talk more about that later in the quarter. Okay, so then we declare some int variables here. So int number of games, total guesses, max guesses, they're set to 0 to start off with. A string variable, again, set to yes. And then we have a while loop. So you can see too, and this is common with like video games, the while loop itself is really the heart of this program. So setting up the variables and calling this method to print stuff up, that's just kind of like administrative overhead. But this is really the heart of it's like the end is the while. So while again dot to uppercase dot starts with y. So let's break this down. So again is a string. And remember, the string data type is a class library. So that makes this an object. And as a class object, all the methods come with it. They're like built into it. So we have this method to uppercase. And if we type the name of the string and then hit dot, brings up all possible methods that are included with that. So one is to uppercase. So we're basically saying, get the string variable again, and whatever it is, convert the values to all caps, all uppercase letters. And that's because the user, it's kind of like cleaning up the data. They might enter lowercase, they might enter uppercase, some mix of the two, we don't really know. So to be consistent, they just convert it all to uppercase. And then it calls starts with y. And this is probably because the user might type yes, or they might just type y, we don't really know. So this makes it more error-proof. So they get the string again, they convert all the letters to uppercase characters, and then they say, does it start with the letter y? And if it does, then it simply continues and it does another loop. If it does not start with the letter y, it continues on, and it gets down to here, and then it calls the method report results. And we'll look at that method shortly here. So then inside this while loop, we have int guesses equals play game, and we pass it console object. Remember, console is our scanner object. So we did a similar method on Tuesday with the resume builder code. And so that just passes the tool that allows us to gather the user input. Okay, then we have an if clause here. We say if guesses is greater than max guesses, put guesses into the value of max guesses. This is kind of realigning. So if I choose the number between 1 and 100 and I choose 50, and it says too high, then this is realigning the min and max values. So if it says too high, then now 50 is no longer the midpoint, it's now the max point. So now the range is not 1 to 100, it's 1 to 50. So that's what this is basically realigning right here. And then it increments total guesses. And then it says, do you want to play again? So let's parse out here. Int guesses equals play game of console. So let's go down this method, play game, and walk through this. Okay, so again, we're still in the class. We're no longer in the main method right now. So we create a random object, random r equals new random. Int answer equals 1 plus r dot next int max guess. Int guess equals answer minus 1. Int number of guesses equals 0. It chooses the number. It has a while loop. Here, it's incrementing number of guesses. So this is keeping track of how many times the user took a turn, guess the value. Simple print statement to prompt for the guess. Console.nextInt, so the user enters a number, it takes that integer, puts it into the guess integer variable. Here, if guess is less than answer, it says higher. Also, if their guess is greater than the correct answer, it says lower. And then this continues to loop as long as they basically guess wrong. So while guess does not equal answer, it continues doing this. When it does equal the answer, they've guessed the right number. And so it outputs, you've guessed it. in num guesses, that's the number of tries they took. It returns num guesses. Remember, this method has a return type of int. So this returns the number of guesses to whoever called it. So let's go back to see where did we call this play game method. So it gets called right here. Oh, and this is where it's checking the max guesses. So if let's run through this one more time just to illustrate this again now that we've gone through the code. So and 50, 75, 80, 77, 76. Oh, what did I do? Oh, I kind of messed up. 65, 55, 52, 51. Lower, I thought it said. Oh, did I do the wrong direction? I think I went the wrong direction. I went the wrong direction when it told me higher or lower. So do you want to play again? I'll say no. So, and then it just outputs the stats. So any questions about this? This is actually kind of a good example because it's showing the while loop in combination with if clause and also the random number generator. And
How come you did a +1 and then -1 a little lower?
when I input the numbers.
It's in the code. Just scroll down in the code a little bit.
Yeah, in the play game method, you say guesses. Yeah,
Yeah,
1
right there.
plus r done extent.
Oh, guess. So answer -1. Guess equals answer -1. Let's put a breakpoint. Random R. Let's put a breakpoint there and I'll run this. So let me run this. 50 higher. Okay, where did it break? Here we go. never hit the breakpoint. Let's see. Okay, let me try this again to try to switch to that breakpoint. Let's see. Weird. Okay. Hold up. It's not even stopping at that breakpoint, actually. Let me double check something. Oh, guess equals answer. That's actually kind of weird. That's the method play game method again.
What would happen if you deleted it and tried to run it? The ones.
Well, I'm pretty sure it won't work. What I think is going on though is, so it's number between 1 and 100. Let's say that the secret number is 25. If I guess 50 and it says lower, then 49 becomes like the new max. I think I kind of lost my place, but I think it's basically I think it's basically doing it's realigning the range. But it gets a little hard to trace because of all the way they've broken this out into multiple methods. So 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 while the user enters Y to continue playing, it says, okay, we're going to continue playing another game. They call the play game method. And that really is getting the input from the user. Then it takes that input and it puts it into the guesses variable. Then it checks to see if guesses is greater than max guesses. Max guesses. answer is the secret number. So it's generating the secret number between 1 and the max guess value of 100. But here, let's see. So the interesting thing is here, inside the while loop, they prompt the user for input. They say console equals next int. Let's say I input 25, and they would put that value into the variable guess. And then it plays the game. But up here, they say int guess equals answer minus 1. I'm not sure offhand why that's necessary. So for instance, I almost think that we could set it equal to 0 to start off with. Let me try that out of curiosity. It almost seems a little random and unnecessary for them to set it equal to answer minus 1. So now let's see if this will work. Okay, lower, 75. Lower. Oh, I keep going the wrong direction. 25. Higher. Okay, so that worked. This looks normal to me. You know, we create this guess variable and we just set it equal to 0 to start off with. I honestly don't know why they set that equal to answer minus 1. That's a little goofy to me. Kind of looks unnecessary. Oh, you know what? So it might be that they're afraid where they have to initialize it to some value and they don't want to initialize it to, like, they don't want to accidentally initialize it to the correct number and then the person would just win right off the bat. So by initializing it to answer minus 1, they give it a value that's not equal to the secret number. It might be that, possibly.
Huh, that makes sense.
So why would you add 1 to the random guess though? If it's finding a
that's down here where they say you got to write in 5 guesses. So they're just keeping track of the number of guesses that we did. So, oh, sorry, up here on line 50.
Yeah, on 53, yeah.
So that's simply the syntax for generating the random number. 1 plus r dot next int max guess. This will basically produce a random number between 1 and 100.
Oh, so if you remove the 1, would it be between 0 and 100?
That's a good question. I think you have to specify it. Let's try it. This is kind of thing to run it in team mode. Am I still in? That or max guess 100. It also, see, a lot of this stuff I have to double check. So it may also be that a random number between, it might be, so 100 random numbers might be between 0 and 99. So they might be adding 1 to it to adjust to that to make it between 1 and 100 instead of 0 and 99.
Oh yeah,
I'd
that
have
makes
to double
sense.
check that.
Yeah, because I think
Yeah.
right here it says distributed int value between 0 inclusive and the specified value.
Yes, I think
yeah,
that's it.
So it's 0
Yeah.
to 99. That makes sense. Okay.
Yeah. Yeah, good question. Some of the stuff I don't remember offhand until I debug it like that.
Thanks.
Yeah, good question though. Okay, I think I have about a little over 5 minutes and I have to go pick up my daughter. Are there any questions I can answer about the homework assignments? Okay, otherwise, so for next week, so again, no quiz on chapter 5, but it's good to review. Again, mostly it's the while loops, the while and the do while loops. Next week, I'll go into greater detail about arrays and multi-arrays. And then after that, we'll get into classes. And we're going to start having some in-class assignments where the programs will be more complex, dealing with classes and object-oriented stuff, but I'll walk you through it during class. So it might be worth like a homework assignment, but we'll, for the most part, complete it during class. So.
I have a question. Are
Yeah.
these quizzes like mini exams? Like, so do we have a midterm?
There's no midterm. It's just the quizzes and the final exam. And the quizzes, I think I set the time limit to an hour, but really, if you've been in class and you even skim the chapter, I think you could probably finish the quizzes in like 20 minutes.
Yeah, okay. Thank you.
Yep. Okay, yeah, so for next week, chapter 7 discusses arrays in more detail. And I'll have more sample code to walk through programs with arrays. So, okay, that's it for today. Have a good week and a good weekend.
Thank you.
Thank you. You too.
All right, thanks everyone.
Thank you.